My name is Lisa Hollinger. I think you all know me, and I'm here to welcome Dr. Christopher Hokamp. He's currently a principal applied scientist at Aylien Labs in Dublin, Ireland. So he's joining us from Ireland today, which is pretty cool that we can have him here, even though he's not here physically. So thank you so much for coming. I want to tell you a little bit about Dr. Hokamp. He leads a research and development team. He designs and implements time series analysis and detection models. And he leads prototyping and implementation of knowledge graph and entity linking systems. His vast experience and varied background includes studies in music, German literature, linguistics, and computer science. He's worked as a teacher, a researcher, an engineer, and technology designer in the area of machine translation, and has studied or worked in the United States, Turkey, Portugal, and Ireland. And I'm quite jealous of his CV, to be quite honest. It sounds amazing. So let's welcome Dr. Hokamp with a round of applause. All right, great.
Thanks, Lisa.
You're welcome. Thank you so much for joining us. I know your time is valuable and we appreciate your spending it with us today. And as you know, we're doing a new format, which is the interview style. And on my way to work today, I was listening to National Public Radio, as I do every morning. And it struck me that the interviewer is just as important as the interviewee to have a good interview. So let me introduce our interviewer today. Her name is Christy Phillips. She's a PhD student in information science with a concentration in linguistics. Christy has a BS in computer science and an MS in interdisciplinary studies with a focus on computational linguistics. You can see her background is in some ways quite similar to Chris's. And her research focuses on building computational tools for low resource language and bias in machine learning. So let's all welcome Christy with another round of applause or some emojis. All right, great, thank you. Now, I'd like to recommend to everybody that while you watch this interview, you put it in speaker mode so that you can focus on the two people that are doing the interview and being interviewed. And I'm also going to turn off my video and turn off my mic. We'll listen for about 30 minutes while Christy interviews Chris, and then we're going to be lucky enough to see some of the tools that Chris is working on currently at Aylien. And then after that, we'll have some time for Q&A. If you think of a question you want to ask while you're watching, just drop it in the chat and we'll be sure to get to it at the end. All right, so take it away, Christy.
All right. First of all, hi, Chris. Thanks for coming.
Hey, Christy. Thank you for doing this.
Yeah. All right. So our first question, and of course, my computer decides to go to sleep while I'm trying to ask it. So can you start by telling us about your current role at Aylien and what major project you're working on at the moment?
Sure. So my role is, I'm called the principal applied scientist, but really it's just like science guy. You know, the way that we're a small team, we're about 30 people, and we've gone through many iterations of our team over about almost 7 years that I've worked here, and the company's even older. And we had like a full-fledged research team just doing research for about 5 years. But as you know, I think it's a typical story of a startup is that you start very broad and then you have to focus and focus and focus and focus. And as we got more and more focused, some of those science roles became less relevant. We didn't let anybody go, but people kind of moved on naturally. And so now we have 2 full-time scientists and then some MLOps people like machine learning engineers effectively who focus on deploying models and stuff like that, more like infrastructure stuff. So I kind of lead that side of the organization, and obviously a lot of like cross collaboration with product, with also with marketing and the other teams that we have. So they call me the principal scientist, but I'm really just like the person that everybody asks about science stuff and the more of like a prototyping, building MVPs, stuff like that.
Okay. And what major project are you working on at the moment?
Oh, right. Yeah. So we're always working on too many things at the same time. Right now, over the last year or so, we've been really focused on time series stuff. So this is both like anomaly detection on time series and then also forecasting. So, given a history, given a bunch of information and context, can we predict where a signal is going to go? And the time series that we look at are things like the volume of news about a certain entity, the volume of news about certain topics, or entities cross-referenced with sentiment, cross-referenced with specific topics. And we kind of refer to these abstractions generally as feeds. and we look for anomalies in feeds, and we try to forecast, like, given what's going on now, what are the anomalies that we're likely to see in the future. So we've worked on that a lot during the last year. And then we've also worked on a lot of general kind of like semantic similarity stuff, focused on things like taxonomy induction, active learning in the context of users like telling us the things that they're interested in and us doing recommendation on top of that. So I'd say semantic search and time series prediction and forecasting are the two major things that I'm working on right now.
Can you give us kind of a broad picture of what Aylien does overall?
Yes, so we're a news intelligence platform. So at the very bottom level of the product is just ingesting millions of news articles every day from sources all around the world. And most of our articles are in English, but we also, I think we have around 20 languages in the platform. So we ingest articles from all of these sources, and then we apply a bunch of machine learning models to them. Things like entity extraction, clustering, topic detection, sentiment, stance, all of these things. Then we index them in a way that makes them easy to search, and that's our main that's kind of our flagship product, which is called the News API. Then over the last few years, we've built a user interface on top of that, which is focused towards risk professionals. So these are people who mostly work in banks, insurance companies, stuff like that, and I think their primary use case is due diligence on entities that they're thinking to loan, maybe loan money to, or that they're exposed to risk in one way or another. And they're trying to do market research or just do research on these entities, and also to check, if something happens in the news relevant to an entity that they track, that they would be notified, and that would trigger some sort of action on their side. So that's kind of our newer product, which is called Radar. And I made demo of that at the end.
Okay. So you've been at Aylien since 2017, even before you graduated with your PhD in computer science. What made you choose this company originally, and what's kept you there for 5 years?
The founder reached out to me. He found me on GitHub, and I liked that. I like to, work with technical people, and I liked the fact that, he was, even being from the business side, he was going as far as looking on GitHub and seeing what people were doing, finding projects that were relevant to what the company was doing, and then reaching out to people personally. And he actually reached out to me not knowing that I lived in Ireland, and it was just a coincidence that I happened to be in the same country where the company was. And so we kind of hit it off. We're still very close friends and close collaborators. So I'd say the main reason I've stayed so long is a really good relationship with the founder. But then, I've always kind of wanted to work in small teams and have a lot of an entrepreneurial side to what I was doing. So those two aspects were the main reasons that I liked it originally, and why I still like it now.
Okay. So how does your knowledge of linguistics make the work that you do today possible?
I saw this question when we were prepping, and I thought about it a bit, and I was thinking these days, even during the 10 years of my career, data science and NLP has changed a lot. In 2010, we had to think about linguistics a lot more. We were thinking about parse trees, constituency parsing, dependency parsing. We were thinking about distributional semantics. We were thinking about formal semantics, a lot of things like that. And these days, it's still useful to have that information, but it's a lot more about just having a ton of data and knowing what to do with it, or having good intuitions about which models will work. I think my work on a day-to-day basis is still very informed by, let me just say the things that I think about regularly. So formal semantics and frame semantics, I think about a lot. I use as a mental model for a lot of the things that I do. Parsing, understanding tree structures and graph structures is very useful in computer science in general. I think that gives linguists especially linguists who are good at syntax, a big advantage in computer science, because that's the way programming languages work. It's like a restricted version of the syntax of human languages. So, and then there's a lot of cool stuff from phonology, like optimality theory. Some of the people who first worked on neural networks were phonologists, or at least they dabbled in phonology. So they're Paul Smolinski and others. So yeah, I think in the past, I've thought about those things a lot. Recently, though, I don't really use OT or anything like that on a regular basis. And then finite state machines, I guess, which are state machines in general, which are kind of very related to formal semantics, are widely used both in practical NLP stuff, but then in computer science in general as well. There's probably other things too that I'm not thinking of.
Okay. So you graduated from UNT in 2013 with an MA in linguistics. What did you learn in the program, or who did you work with that pushed you in the direction of natural language processing?
Yeah, I got really lucky actually. So I would say my biggest influence while I was at UNT was Dr. Montler. I thought he was a great teacher, but he's also a programmer. And so he kind of inspired me that, you can self-learn and that you can get good at this stuff just by being interested in it. But then I got super lucky that Dr. Rada Mihalcha, who has since moved to the University of Michigan, was at UNT during that time. And so my very first semester at UNT, I took the natural language processing course just as an elective. Like a little bit more background is that I was very interested in linguistics for a long time before I did my master's. And I was thinking for a while, like, wait, you can do all this stuff with computers. And I always tell the same story. I thought like I invented the whole field of NLP because I was just completely oblivious that people had been working on this for like 60 years. It's one of the first things that people ever did with computers was like try to do stuff with language. But once I realized that that was a thing that you could study, I was very interested, but I didn't have a computer science background. So I had no chance of getting into, a master's or a PhD program in computer science. So I kind of went the linguistics route, but always with the intention of going like in the computer science direction as quickly as possible. And I had I really liked the UNT linguistics program. I'm still close friends with many people from my program. We had a great cohort with some really smart people. And the field linguistics, both Sadaf Munchi's course and Dr. Montler's, Shobna's syntax course, and I'm sure others that I'm not thinking of now, but it was a great environment for me in general. I would say, like career-wise though, my work in the computer science department was really what took me in this direction. And I worked in the lit lab, Dr. Mihalcha's lab, and then Rodney Nielsen came, I think, in the last 2 semesters that I was there at UNT.
Okay, so you said you came into computer science later on. So did you find that difficult? Did you find it difficult to transition from linguistics to computer science, or?
Yeah, well, yeah. I mean, there were several years there where I wasn't really doing much else, and I was around 25 at that time, and I had never taken a computer science course. I mean, I had been a hobby programmer, kind of like dabbled a bit here and there, but I wouldn't have been able to write any sort of like coherent program at that time. So I had a lot to learn, but I was really, I still am very interested, but at that time I had 3 or 4 years where I was like super passionate about it. And it's really kind of like all that I did. And that was enough time, I started just seeing when you spend that much time doing something, you can get good at it pretty fast. And I think I had an aptitude for programming, but I think, anybody who is into linguistics and can understand linguistics is likely to have an aptitude for programming as well, because there's a lot of crossover in the ways of thinking, and so yeah, I guess I don't know if that answers the question, but
I think it does. Sometimes in the past I have taught some intro programming, like little courses, and I always am telling the students, especially the linguistic students, as they come in, like even just a little bit of Python can help you do your work. Just a little bit of coding skill. Like you don't have to be an expert to make your process easier, because you're trying to process so much data. All you need is a little bit of skill. Yeah.
Yeah, I think I've heard many people who are into programming say that they're very lazy, but they're lazy kind of like in a smart way. And so that has rung true with me over the years, that like a little bit of automation actually can save so much time. And I still have to sometimes remind myself, like I should be spending my time automating this as opposed to banging my head against the wall or whatever. And I think automation often, it's similar to writing in that it clarifies our thought process as well. Like if you can automate the core of something, or the the part that's very tedious, it shows that you really understand it. You really understand what you're trying to do. And so I use coding a lot as a thinking tool, just to kind of like be honest with myself that I actually even understand what I'm trying to do.
Yeah, I think that's really interesting. Yeah. So we've kind of already talked about this, but you started programming for real when you were 25. So how did you get started? Just liked the idea, or?
Yeah, like I had a bunch of ideas, but the one that really stuck was to make a program that could freestyle rap. And that idea really like stuck with me. And I thought, I always liked hip hop and always was like interested in rhymes and stuff. So I thought like I have a mental picture of how this could work, and can I build it? And that was the first like real thing that I built. That was my final project in the NLP course, the first semester NLP course that I took with Radha, but I had been thinking about it for a long time before that. And I think I wrote it in Java, and of course did all sorts of like stupid things. And then I rewrote it in Perl. And yeah, that was my first like big project, and that really clicked. And it was, as you do, I bit off way more than I could chew, but I learned a lot from that project. And at the end, it did work. And I remember, even that was like in 2013 or 2013, and demoing to the class, like given a prompt, just would generate a freestyle. And now with like all these GPT things and everything, it's like people are, of course, it's kind of like trivial to do, but 10 years ago it was cool.
Yeah. So you said you went back and rewrote your code. It's always kind of embarrassing, right? Go back and look at your old code and you're like, oh, why did I do that? Even like 2 months later, it's like, man.
Yeah, that person's such a, yeah. Yeah. I mean, we can maybe talk about some best practices in a little while, but yeah, absolutely. I mean, I guess it's just like anything when you kind of, hopefully, you're always learning and growing. So when you look at your old self, your past self, it's kind of can be embarrassing at times.
Yeah. So what would you recommend for people that are just starting out in computational linguistics or data science or machine learning?
I guess it's always good to know, to have a project, like to have a reason, something, and that's kind of easy to say, but like I think that for me, the most effective learning is always done when working on something real. If it's a class assignment, that's fine. And of course, classes are good and they're one of the most efficient ways to learn. But there's a saying that all programmers are self-taught. And I think that's true. Everybody kind of has to figure out their own way of doing it, what works for them, what makes sense to them. And everybody kind of comes into it there's different things they understand, different things they don't understand. So I find that working on projects is the best way. And another thing is that it gives you a tangible artifact, hopefully at the end, which just has practical implications. You can use that artifact to get your next thing, to start to bootstrap your next project. You may be able to use it to get a job or whatever. So as opposed to kind of textbook learning or working through problems or whatever, I definitely advocate the project-driven approach.
You said your current boss found you on GitHub. So did he find things that were just projects that you'd worked on, not things that you'd necessarily done?
Yeah, he actually found, it was Google Summer of Code, which now I can say it, I completely like oversold myself even signing up for Google Summer of Code, and effectively just made it look like I had a lot more experience than I did. And it was really competitive. It's a summer-long thing where a bunch of open source projects effectively host students, and they pay you. They give you like a stipend through the summer. So I was lucky enough to get into DBpedia Spotlight. Again, way over my head, but I learned so much over that 3 months. And that's how he found me, which in DBpedia Spotlight was a big open source entity linking system. And the paper that we wrote about that is still one of my most cited papers today. I think it has like 700 citations. And so he found me through my contributions to that open source project.
That's neat. So, so what's your current tool set? What technology stacks do you use and why?
Yeah, okay. I can share my screen, right? Yes.
Yeah, you should be able
to. Because I have a slide about this. I'm just gonna Let me just share like this. All right. Can you see the text there, or is it way too small?
I can see it, so I think
okay
for everybody.
I'm not going to say every one of these libraries, but I'll just list a few. I use a lot more libraries than this, but this is kind of like an opinionated stack of some libraries and tools that I think everybody doing data science and NLP right now should know. Python. So short answer to your question is Python is number one. And I love Python. You know, once I started coding in Python, I of course know several other programming languages that I'm comfortable in, but Python was like the one that really clicked for me. And now I've been coding primarily in Python for like eight years. So there's some libraries that are really good for NLP and Python. Spacey, I think, is one of the best. You get just pretty much everything out of the box. PyTorch is more just a general purpose library for machine learning, but it has a very nice syntax that's kind of, I think, easier to grok than some of the others. Then Hugging Face is this, you know, big project. It's grown so much over the years. Probably a lot of people have heard of it, but they have their main thing that's really cool is that they have a bunch of pre-trained models. And now that we use pre-trained models as a starting point for just about everything, it's a great resource to just find a model for pretty much any task that you can think of. I'm not going to read all of these. I really like the Jupyter Notebook for fast prototyping. I wouldn't recommend it though for, you know, actually building production stuff or like permanent code. It's really just for fast prototypes, and then your code should go somewhere that's easier to maintain. I use Linux exclusively. I also have a MacBook, but I mostly use Linux. I don't like Windows at all. Then learning Git is, I think, very important. It's cool to learn about, but it's also super useful just for maintaining your sanity. Then I like IDEs. So VS Code is the one that's free that everybody uses. Actually, I use PyCharm, but it's not free. So I advocate for people to use VS Code, and I think that's kind of the de facto IDE now. Scikit-learn is just a library of a bunch of machine learning models. I'm sure you've heard of it or used it before. And then for demos, Streamlit is this really cool library. Have you heard of that, Chrissy, before, Streamlit?
I don't think so.
Let me just switch my tab real quick. You can make anything. You can make little apps, but the cool thing is that even if you know JavaScript, you can write your whole front end in Python. So for a Python person, it's way faster than building a web application and having to deal with like HTML, CSS, TypeScript, JavaScript, React, Angular, all these libraries. It's maybe not as slick as a real web app, but it's really fast for prototyping. So I really love Streamlit. We've used it on my team for 2 years for a lot of different prototypes and demos. I'm showing just our entity linking system demo. We can dive into this more if we have time later, but this is just an example. But we've made at this point like at least 50 different apps in Streamlit. So I really like that. Then the rest is kind of ops stuff, so infrastructure stuff. But I think this skill set is one of the ones that in industry is the most valuable. So if someone who was like pretty comfortable coding and had like a good broad understanding of NLP was just looking for a job, I would say this is the best bang for your buck to learn about Docker, so containerization, deployment stuff, either GCP or AWS are the main ones that people use. There's also Azure or others. How to like actually run stuff in production. So how to wrap it up into a container, how does it scale when you get like lots of users, how horizontal scaling, this kind of stuff. At this point, all of the tooling for this is very mature, but I think this is one of the skill sets where data scientists are typically the weakest, and therefore it's one of the ones that's like the easiest to capture value if you learn about it. You're competing with a lot fewer people because not many data scientists are like proficient in the infrastructure stuff. These are just libraries. I won't go into FAISS or Elasticsearch unless someone wants to ask about them. A couple more tools. I'll drop all this into the chat. I have a few tips here. I'm just going to see. Oh yeah. I'll stop here for now, and then in the demos, I'll cover something else. I'm going to drop all of this into the chat now and stop sharing my screen for the moment.
It's funny that you mentioned Overleaf. I find that a lot of professors don't want Overleaf because they can't comment on it. So they don't want you to just send them a PDF.
But you can comment on Overleaf though.
Well, I know, but they don't use it. They want a word
Okay.
document like they're used to.
That like changed my life, because like dealing with LaTeX compilation locally is, I guess it may be better now, but I've used Overleaf only for years now, and I find it so much faster. I wrote my whole PhD dissertation in Overleaf.
That's my plan too. Let's see. So what advice do you have for students that want to go into the field that you work in, but aren't quite sure on how to prepare themselves?
Like, I mean, it kind of goes back to that project thing. I would always advocate for grabbing projects, because, you know, at the end of the day, whatever we choose to do with our lives, we're going to be spending a lot of time doing it. So I never think that someone should do something just for a career. If you are just, you know, of course we all have to like make a living. So there's practical things, there's reality to deal with, but I would advocate grabbing projects that are hopefully bite-sized and going that way. There's going to be a lot of Googling involved, a lot of like self-learning. And I mean, that's kind of generally my number one piece of advice is to do projects, as many as you can at the beginning, but small ones that you can actually finish. So, you know, we all, especially from the academic background, we all have many like unfinished projects that we're planning to come back to at some unknown point in the future. But, you know, it's good to, that's stressful. Like, it's good to try to minimize that as much as possible, and try to keep things like bite size. And even if it seems bite size, it's usually like a big mouthful, you know, in reality. So I advocate starting like trivially simple and trying to just build stuff. And, you know, some people will like that, but some people don't like that. And if they don't like that, I would say try to go in a career path that's more like interpersonal, requires more communication with people, because this career path doesn't, the reality is you're kind of like a loner sitting in front of your computer a lot. And for some people, like my personality type, that's great, but other people might not want that. They might want, you know, more human contact, more interaction, and those type of roles are also very valuable and very, you know, needed.
Yeah. Christy, did that bring us to the end of the questions?
Yeah, so that's the end of our list of questions.
Okay. Before we move on to your presentation, Chris, I'd like to just go ahead and cover a couple of the questions that got put in the chat. By the way, thank you, Christy. That was a great interview. I'm so glad you did it and not me, because you were able to ask follow-ups that I couldn't have asked. But Hugh Patterson has a question in the chat, and I'm not even sure I can ask this question appropriately. Hugh, if you'd like to turn your mic on and ask it yourself, you're welcome to do that. But if you'd like me to ask it, I can.
Sure, I can ask away. Great interview. Thank you very much. So I come from a functionalist background, which maybe the linguists in the room might understand the difference between functionalist and formalist grammar. But I've followed the NLP world and the machine learning world quite a bit. And I'm wondering what your take is on functionalist approaches contributing to NLP in the under-resourced language communities for NLP related to functionalist approaches versus more formal syntax approaches.
Well, so that's a good question and a very interesting topic. I think, for one thing, there, in my opinion, has been a lot of progress in low-resourced languages, especially over the last like year or two. Fine-tuning, domain adaptation, transfer learning, all that stuff is really taking off now. And so, you know, my opinion is that data is going to solve not everything. There are always going to be like edge cases or weird idiosyncrasies about every language that you kind of, I think it's going to be a very long time until AI gets to the point where it can understand, you know, jokes that are based on like multiple levels of recursion in like an ablative, like there's always going to be edge cases, but most of the cases will be solved by just gathering more data. And what field linguists do, like elicitation, we're already in that paradigm where models can do their own elicitation. And that area of research, active learning, has been an area of research for a long time, but it's really kind of taking off now, where models kind of have a sense of what they don't know, and they just elicit those things. But in terms of, I'm not sure I know exactly what you mean by functional syntax. Can you clarify that just for a second?
Yeah, so in formal syntax, we have a lot of trees that, and movement. XPAR theory has a lot of movement kind of things, and even in optimality theory, we have different ways of expressing that, right? And more functional grammar goes and looks at why is this? What's motivating this functional approach to all sorts of things? So there's a linguist out of New Mexico, right? He did radical construction grammar, looking at the way that
I'm a big fan of that. Yeah, I've read the radical construction grammar book.
Yeah, so and that's much different than approaches to traditional Chomskyan tree-based things that look more like finite state machines.
Yeah, absolutely. So, I mean, I think of radical construction grammar or construction grammar in general has really been borne out by all the big data stuff and deep learning, where if it's kind of like the distributional hypothesis of Firth. Like all the kind of atoms of language are defined by the contexts in which they occur, and it's like this big graph. And in general, that's like the abstraction that applies everywhere. So not just to language, like to intelligence in general. Things like playing Go, playing chess and stuff too, but language fits into that. It's broad enough and abstract enough that you can also fit language in there. So yeah, I personally think that's the way forward. And with regard to low resource languages, it's about, finding the constructions that you don't know about, or, some measure of like entropy or something in if you have a template, like a construction grammar template, there's some places where you have question marks. You're like, I don't have enough data to fill this slot or to induce a probability distribution over this slot. So I need to ask the native speaker to give me some data to fill those little holes. And I mean, that may not be exactly, that's too hand wavy, but I think that's how we're going to fill in all those holes going forward.
Okay, thank you for your question, Hugh, and thank you for your answer. There's one more question in the chat from Peter. And Peter, if you want to unmic and go ahead and ask it yourself, you're welcome to do so. And then we'll move on to your presentation. Go ahead, Peter.
So Hugh and I actually typed our questions at the same time. While you were talking about formal phonology and formal semantics and formal syntax, I also studied both functional and formal approaches myself. Obviously, if you have a background in endangered language linguistics, you're probably doing functional, or you're trained at functional at some point. But for me, the big breakthrough actually came through by studying formal approaches. And as I was listening to your presentation, I wondered, as you mentioned formal semantics and formal phonology multiple times, if I was a student, if I was a master's student in my first semester right now, and I want to transition to a tech career, not a language conservation career, would I be better served studying formal linguistics over functional linguistics? As you were saying that computer science works a lot like, the way you do with language works a lot like the syntax trees, is this kind of thinking, I'm a linguist, I'm trying to transfer to tech, which kind of, you see, I've got 3 questions right there kind of related like that. One is just about your rhyming. I wanted to know if you could if you'd already had a GPT-3 model that could rhyme, and you literally said right after I typed it, it would be trivial to make them rhyme. So you can skip that one. The first one is just, are formal linguistics more useful for someone in your career than functional linguistics?
I don't know. I mean, I don't know. So great questions, Peter. And Peter and I riff about linguistics all the time, and I feel uncomfortable sometimes answering his questions because sometimes I feel like he knows much more than I do. But I'll do my best. I think both are useful. The good thing about formal, especially formal semantics, like lambda calculus, stuff like that, is if you get that, you have that's functional programming right there. All you have to do is learn like how Haskell does it or how Scala does it, and you're good to go. It's exactly, the people who built those languages, that's exactly the way that they were thinking. And they just effectively translated it into making a computer do it. So if you're going down that path of, and I think functional programming is very beautiful and it's very just elegant. And so that's why I think formal semantics is interesting, but you also don't want to go down these rabbit holes of like crazy symbols and stuff. It's kind of like, it's like martial arts, like kind of absorb what's useful, but quickly avoid rabbit holes. Like if you're working on something for more than a week or so, it's probably not, there's diminishing returns there. It's more about like intuition and stuff, in my opinion. And then the what you guys are calling functional stuff. And honestly, I really haven't used those terms much before, but construction grammar, for example, I think that that can be induced from very large data sets, which is what we do in practice or what we ask our models to do. So GPT, for example, I'm sure a linguist could come along and extract frames from the GPT parameters and show how it like induces distributions over its slots, or Winograd schemas, stuff like that, or close deletions, all that kind of stuff. So I find those abstractions useful and applicable, on a day-to-day basis of like what's static, what is like flexible in this template.
Okay, Peter, did you get your question answered? Yeah.
Yeah, but there was one follow-up. It's still related. And I'm asking this specifically because I'm teaching phonology to a bunch of linguistics MA students. And I'm going to teach tonight. And I'm going to say, hey, if you want to go to tech, one hint is this. The second thing I wanted to know is, what kind of projects might you recommend for linguists interested in training for a tech career?
Well, especially for phonology, automate your homework. So that's the way. I think Dr. Montler had a really popular website for years. I don't know if it's still up, where you could, I can't remember exactly what you could do. I think you could drop in text and it would render the IPA or something. It was something like that. And it had I think it had some crazy number of hits, like 50,000 a month, just from people. I don't know if they were doing their linguistics homework or it was just like a useful tool. So building tooling for your own workflows is always a good thing to do. And that goes back to like the automation that we were talking about before. So yeah, like in phonology, there's a lot of little algorithms or little loops that if you apply this process, you'll get to the answer. So just, see if you can do that with a computer instead. I think those are always good kind of low-hanging fruit type projects. But then it's also kind of about what you think is cool, or if you have a cool idea, try to do it, or try to do a simple version of it.
Great.
So we're doing this phonology book, the same one you did with Montler. Of course, it's literally the exact same book. Chris and I were in phonology together with Montler. And if I were a student and I could build a program that would solve even a single puzzle, that would be a good starter project.
Yeah, absolutely. That means you've extracted like the algorithm from the class. So, a lot of linguistics, that's what it is like someone's trying to find an algorithm for something which we think is implemented in our brains, or either we learn it or it's like there. And if you can implement that in code, then that really shows like you understood, or at least like you understood how we think it might work, or what enough to solve this problem. Yeah, so I think that's a great place to start.
Okay.
Thank you, Chris.
Thank you for your question, Peter, and thank you also, Chris, for your answer. Let's move on to the next part, which is where we're going to learn some cool stuff that's happening at Aylien. And then we'll see if you have other questions while he's presenting. Please just drop them in the chat.
So this is our new UI. It's targeted at people doing risk analysis, and it's kind of focused on that. This guy has configured a bunch of feeds, and we'll see his feeds render. So we're looking at cyber risk now, and you see things like news volume, and then a bunch of clusters that are like the top stories for what's going on in this feed, which is like a custom configuration. So here's one about the New York Post being hacked. And then we can drill down into the event. We see things like the top industries, the categories, the entities, sentiment. So tracking sentiment over time. Some of our users modeling this type of stuff would be like would have signals based on how sentiment is changing with respect to this feed or this entity. We have a bunch of tools built in here. We have these matrices, which are like matrices of signals, which tell you they have topics across the top and they have entities on the y-axis. And so this user is effectively tracking like 100 entities across these topics: corporate funding, finance management, liquidity risk, and market updates. This one's in the anomaly zone. So they would drill down and try to figure out what's going on. Here, it's this probably a supplier of Apple filing for bankruptcy. That's what triggered that anomaly. So these tools are targeted at our customers, who are, like I said before, tracking risks. Let me show you some more like sciencey demos real quick, and then if anybody has, I want to leave time if anybody is interested in something specific. I showed this tool, which shows our entity linking system, how it works. So let me see if I can grab some text. I'm just going to grab some text from the UNT Linguistics website. See what's going to happen here. This is what our internal team uses to kind of check what our models are doing. I added that text. So we correctly recognized Chris Morphew as a person, but he's unlinked in the knowledge base. Some other entities. We also recognized Hash, but we don't know him. So that means that there's not an entity in our knowledge base for Hash. So one thing they can do is add a rule, which is effectively like doing an annotation. And they would have to initialize the entity in our knowledge graph, but let's assume they did, and it has some random ID. And they assign it the type person. And then they can add contextual rules, which means it's like based on vector similarity, or they can add a global rule which says like do it everywhere, always do this. I'll add a contextual one just to show. This is the context for that rule. So it's like when you observe that entity in a context similar to this, apply this annotation. And then once they add that rule, this is just a demo, but it will propagate through the whole system. And after that, the entity will be correctly annotated. Let me make sure that this actually works.
So I have a question because I saw that. So this could be my eyes, but I think, yeah, you have a spelling error.
I spelled it wrong.
Yeah. So then my question is the computer smart enough, or is the program smart enough to know that you've just had a spelling error, or will it not work because of that?
So that's a great question. And, in practice in building, NLP products for actual humans, these are like design decisions that we have to make. Like how much spelling correction do we want to do? Maybe we'll correct the spelling, like when you're typing in your phone, maybe your phone will autocorrect in a way that you don't want it to. So there's always going to be some trade-off. And the short answer to your question is we do try to like normalize the text, but we're very conservative about that because we don't want to do an action that is like totally different than what our user is telling us to do. I think from the data science or machine learning perspective, what you really want all these decisions should ideally be taken in a data-driven way. So if we see our users like making a bunch of rules that never fire, or if we see our users making, giving annotations that don't match anything, then maybe we should say like we need to do more normalization or try to be smarter about how we match, with Levenshtein distance or another string like edit distance or another smarter way of doing it. But I guess the short answer is we do a bit of that, but we're very conservative. So in that case, it didn't fire. But you can see once I fixed it, it did fire.
So like with everything, it's a balancing act, finding the right spot to go to, if there is one.
Yeah. Let me show you. Let's see what else I can show you. Actually, do you want to guide me here? So of these topics, is there, Chrissy or anyone else, is there something you want to see a demo of or to talk about?
I think the sentiment analysis might be interesting.
Okay, absolutely. So sentiment is a topic that is like, it's kind of the bane of all NLP platforms because, sentiment is something that non-technical users intuitively understand. And everyone has the idea of like, ooh, I'm going to see, are they talking negatively about Tesla? If they are, I'll like sell my Tesla stock or I'll like short Tesla stock. So these ideas like occur to people all the time. And in reality, like sentiment analysis, in my opinion, is a very underspecified problem. So like meaning that if I give you a text, if I hand you a text and say, is it positive or negative? It depends on who you are. It depends on your context. It depends on a lot of things that I didn't specify in the task. And so what we do is called ELSA, entity level sentiment analysis, meaning we're asking not is it generally positive or negative, but is it positive or negative with respect to this entity? And even that is very underspecified. So, depending on which news site you're looking at, they may have a bias against certain entities, like political entities are the classical example. So there's other extensions of it, like targeted aspect-based sentiment analysis. I don't want to overtalk here. Let me just show you the visualization. But yeah, it's a, go
Can I ask
ahead,
a
please.
question?
Please,
Do you
yeah.
guys handle things like sarcasm? Like, do you have any?
Yeah, well, our models are kind of like state of the art. So there's training data in those models that is sarcastic. So you would hope that, you know, if there's that type of sarcasm in the training data, then the model would learn, you know, typically sarcasm is if it's sarcasm, you kind of know it's probably negative. So I would hope, but we don't explicitly handle sarcasm. We just hope that it's in the training data. I'm trying to show a visualization of this. Sentiments. We saw it at the beginning. Actually, if you look at, this is just a blog post that we wrote recently. I'll share this link in a minute, but here we go like we drill way down into the sentiment of different entities over time, positive, negative. And, you know, like I said, the classic thing is to track these with respect to market data. It's maybe not that interesting, but the good thing about market data is that it's free and it's like everywhere. It's easy to get. I'll put this post in the chat if anybody wants to read it. So those are the kind of things we do, but I'm always like a bit skeptical about sentiment unless the use case is very well defined. I don't know if that answered your question. Sorry, Kristen.
No, I was just interested in how you guys, what you guys worked on in that area. So I think
The short version is, you know, we take, like, I'm not going to reveal exactly how we do it, but we take the best model off the shelf from the research and we fine tune it for our use case in a nutshell.
Yeah.
Sometimes we collect data using Mechanical Turk or internal annotation and fine tune it towards our use case. But our current sentiment models are like the deep learning based ones, so the transformer based ones. And there's a trade-off between those models are expensive to run in production. We're processing over 1 million articles a day, and those need to run on GPUs to be fast enough. So the business there has to be like business decisions. Is it worth it to spend this much money? Are we getting more customers because of this? I don't make those decisions. We usually just train the models and show what they can do, and then pass it to the engineers and the operations to make the decision of whether they're going to do it or whether there's typically something that's like a lot cheaper but not as good. And you know, we always have to make those trade-offs.
And we do have another question added to the chat from Shobana. It says, what should our students be thinking about in discourse analysis or other related classes to improve sentiment analysis?
Yeah, that's a great question. Discourse is still like wide open from a NLP perspective. You know, document level stuff is still documents that are more than, you know, 10s or 20 sentences are still a very wide open research topic. Right now, we kind of pack everything into fixed size vectors. So, you know, the longer, just by necessity, a longer document contains more information, meaning you're compressing it more if you pack it into a vector of the same size. And I think a lot of people are working on that, but nobody really knows the answer. I think so. I haven't worked on discourse with regard to sentiment analysis, but I've worked on discourse and machine translation a lot. And it's typically a hierarchical representation. So the same way that when we write, there's kind of like a schema of our documents, meaning like there's a title, there's an introduction, there's paragraphs, there's chapters. So making use of that implicit schema and then making use of the natural delineations of like units of meaning or units of text, like sentences and stuff like that, and then constructing a hierarchical representation. I think graph-based stuff is very promising there. If you imagine like a tree, if you have a book like Moby Dick or something, and if you imagine Moby Dick, all the pages just spread out in a long line, and then a big tree growing out of all those pages all the way up to the very top node, which would be like a vector representation of all of Moby Dick. And our job is to like traverse that graph in the right way and learn the implicit representations or the latent representations of those nodes with respect to some downstream task, like summarization is a good one. Summarize this document, summarize this chapter. So yeah, I'm happy to follow on there, but that's kind of like how I think about it.
Okay, thank you. Is there something else you wanted to see on that list, Christy? We have time. We have about 7 more minutes, so I don't have another question in the chat. If you have time to look at one more thing.
Yeah, we can do named entity recognition, I guess, entity extraction.
Cool. So yeah, entity linking and entity extraction is one of the topics that I've worked on the most. It's one of the first things I worked on in natural language processing, and I still work on it today. It's a very interesting problem because the space of things in the world is always growing, and it's very, very huge. Where, you know, depending on the space, the types that you care about, like do you care about people, companies, things, species of animals, etc. You're easily, usually in the billions of distinct things. And the job of entity linking is to, given a mention in text, like given someone saying Chris, which Chris are they talking about? So this is relevant across pretty much all applications of NLP. Big search engines obviously do it, like Google, and then governments and NSA and all sorts of like, anybody who wants to track people is also doing some sophisticated entity resolution. Banks do it for fraud detection. When your credit card fires, it's some form of entity resolution. So it's kind of like ubiquitous everywhere. But it's a cool problem because you have to quickly narrow down the set of candidates very fast. If I see a mention of Chris, I can't check every Chris in the world. That would be way too inefficient. So I have to do very fast, extract the candidates of like, which Chris could this be? And then quickly, and then I can apply like a heavier model to that second step. So that first step is candidate extraction, and the second step is actually like scoring those candidates. And it's very similar to the way that search engines work, but it's kind of like an application of the same idea to a different problem. I think it's still unsolved. Even Google knows who I am when I Google because I'm signed in for the most part. So sometimes it's trivial, but if I just typed Chris into Google, it wouldn't really know anything about what I was looking for if I wasn't signed in. So there's always kind of like this balancing act between like how confident am I, how much information do I have, what do I know about the user, what do I know about the world, and we have to just like do the best that we can. I'm happy to, if you have a follow-on question, I'm happy to drill down somewhere there for a minute if you want to.
Just as a follow-up to your last answer from Shobana wrote back, she said that kind of structure mapping of discourse would be helpful in language description as well in looking at particles that chunk clauses into episodes, for example.
Yeah, absolutely. So, like syntax, I guess, is we're within one sentence or within one utterance or something. And then you can think about if you have that syntax for all of the utterances, building a tree on top of all of those. And it doesn't have to be, it's really a graph, not a tree, because when you're thinking of it as a tree, you're always like really constraining what's possible. But let's say it's a graph and it's mostly a tree, meaning there's a lot of leaves. And then I think it's that way of thinking about the world is useful everywhere pretty much. It's just a nice way to make complicated things a little bit simpler, is imagining this latent structure.
And I realize we jumped in between topics there to go back to that. But Christy, did you want to follow up here with anything? There's one more question in the chat, but I'll let you follow up on this first, Christy.
Oh, no, that's all right. You can go ahead and go to the chat question.
Okay. All right. So in the chat, Sandy asks, does the platform compensate, adjust, or learn culture-based expressions? Example, don't throw the baby out with the water. She says water, but I was going to say bathwater because I'm clearly doing predictive text analysis there.
Like right now, the answer is if it's in the training data, then yeah, it learns it. If it's not in the training data, it doesn't learn it. I think there's a lot of work. So the role-based thing that I showed with Haj's name earlier is like a very simple example of how a user with domain knowledge, meaning like a native speaker or someone with knowledge of like bias, gender bias, anything like that, might give feedback to the model that says like, I know you saw that in the training data, but don't do that. So some sort of like cultural context and there's a lot of people working on that. It's a very interesting area of research. I have a close friend, and her PhD thesis is about gender bias in machine translation, and especially in languages that have some languages have ungendered pronouns. The biases that get passed down from the training data they can be really big. And so it's not a topic that I've personally worked on a lot. I kind of just trust that the research community is going to figure it out. And I'm mostly an applied scientist, so I try to just build things for users, like for people trying to accomplish a task. Of course, I'm interested in the social implications of these models, but I kind of like trust people with more expertise and just do what they say to do, pretty much. But yeah, like I guess the short answer is that if it's in the training data, it learns it. If it's not, it'll be completely oblivious to it and may do something like hilariously bad.
I think we've all seen hilarious translations as we've traveled around the world and seen people doing, direct word for word translations and things like that. I suppose it's getting better now as the machines are smarter and the machine learning is possible.
If you translate, like perfect translation is you solved AGI, like you solved AI. And I think we'll get there, meaning perfect translation, like at human level. Mm-hmm. Of course, many things are untranslatable. There depends on like cultural things that you can't translate, or you have to explain. The person has to have a lot of context to understand it. But as much as possible, that it's a very difficult problem, which is why it's interesting. And there's a lot of languages in the world, which is another reason it's interesting.
And I'm personally very glad about the fact that it's such a difficult problem, because I taught English for 23 years to people who don't speak English. So, I did not become obsolete because of all this, at least not yet. Absolutely. Maybe, and now I've trained jobs. So perfect. I think we're coming up 1 minute left on the hour. If anyone wants to get one last question in.
I can ask something. So do you guys end up dealing with much misinformation or fake news?
Yeah, of course. I mean, we consume news from, I think it's like 50,000 sources. So, there's a lot of fake news, but the good thing about news is that by being a reputable source, you can sort of trust that there's humans on the ground who are checking that it's okay to publish that information. So this makes our domain a little bit easier than like social media or stuff like that, where you have no way, or it's much more difficult to do fact checking or verification. In our product, we have like premium sources, which are kind of like A-list news sites like New York Times and stuff. And so if it's coming from them, I effectively trust that they've at least done their due diligence. And, they wouldn't publish something that is known to be false. So that simplifies our domain a bit, but I mean, it's a problem for sure.
Yeah. All right. Well, I'm going to wrap this up. Christy, thank you so much for interviewing Chris. And Chris, thank you so much for taking this time to be with us in the afternoon. You're probably ready to get off work and maybe go enjoy some more. I guess it's All Saints Day today, right? Or after Halloween, maybe there's more activities going on in Ireland today. And
thank you.
You're welcome. And thank you to everyone who came and joined us for this hour. The recording will be online soon, so check back on our C.O.D.E website if you want to watch it again. Thanks, everyone.
Thanks, Chris.
Thanks. Good to see you.
Nice
Bye.
to see you. Bye.